Hi everyone, in this video I'm going to kind of recap some of the ideas that we talked about in the beginning of Module 11.1, sort of an introduction to how to find probability, as well as use that as an application to find some more generic outcomes of probability. I'll start to talk about 11.2 in a little bit of detail, that way you have a little bit more exposure overall. So in this video we're going to go through 11.1, just some of the big topics, maybe an example or two to refresh your memory, and then apply some of these new ideas to 11.2. So just as a recap, some important vocab is that an experiment is any observation of an event that's measurable as a random phenomenon. So this can be almost anything that you have a desired outcome to look at. Like we normally talk about rolling dice, spinning a wheel of some sort, pulling cards from a deck, randomly selecting maybe marbles from a bag. All these are instances in which there is a random element that changes the outcome of the event. So, and in those experiments we have outcomes. That's actually the result of an experiment, and we can kind of generalize that to a sample space. That's sort of the ways that we think an outcome can work. So I could think of, again, if I draw a little dice here, a dice has 6 sides, and I'm just showing sides 1, 2, and 3. But if we think about the experiment of rolling a dice, and then the outcome might be whatever rolls at the top of the dice, my sample space would be the numbers 1 through 6, because those are the actual possible outcomes I could get over all of those experiments. And we talked about theoretical probability. This is the type of probability we use in most cases. And we use sort of the generic formula, the number of outcomes of favorable outcomes over the number of total. If you recall, I don't really like to use the word favorable. I prefer the number of desired outcomes, like what we want to happen, over the number of possible ways. And that's going to give us our generic formula for probability. Now, this right here, it says N of E. This really just represents the number of events we want. This represents the number of the sample space that we want. And then we also talked about what we call empirical probability. Now, this is a little bit less useful in terms of standard calculations, but this is a probability based on a set of observations where we look at the number of times an event has occurred over the number of times it was performed. So in class, if you remember, we talked about flipping heads and tails, and we really had a lot of heads. I think we had, in all the times we flipped the heads, I think we had 13 heads, and I think we only really ended up having 6 tails. So with the probability of the empirical sense of flipping a heads, we would deem that probability 13 out of 19, because we had 13 outcomes that we wanted, probability of rolling a heads, out of the total number of times it was performed. Well, we flipped a coin a total of 19 times. Now, of course, that completely contradicts what the actual probability of flipping a heads is accepted to be, which is 1/2. 13 over 9 is very, very skewed heavily that heads will happen more often than it really should. So we like to understand what the difference is between empirical and theoretical. This theoretical is what we will use for all of our computations, unless it's specifically given to us in a sense of empirical data. So now here's an example where it is an empirical data sense because it tells me the number of possibilities. So this is my total number of outcomes. And then it's actually telling me the number of ways this could happen. So it kind of works in both regards, in that the probability of getting a straight flush is 36 out of 2,598,960. And I remember this was a very, 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 very small number. I think it was 0.0001 something else. But the idea is, no matter what, I mean, we're not even talking about the problem itself, but the idea is if I know the number of ways to do something and the number of ways I want that to happen, this would be the way I find my probability. Then we talked about odds, and so we used a twister board. So let's kind of zoom in on this twister board here. So again, we talked about thinking about labeling all of these as a specific outcome. I get blue foot left, yellow left foot, green left foot, red left foot, blue right hand, yellow right hand, green right hand, red right hand, blue right foot, yellow right foot, green right foot, red right foot, blue left hand, yellow left hand, green left hand, red left hand. So in each of these categories, there are 4 outcomes. I mean, we could even think of this in sort of a quadrant level. But if each quadrant has 4 outcomes, so there's 4 total here, and 4 total here, and 4 total here, and 4 total here. On this board, there are 16 total outcomes, no matter what. And I'm going to revise my map here to show that. Kind of lost track of what I was counting and just recounting the numbers, I just realized. So 5, 6, 7, 8, 14, 15, 16. Now, we can think of the odds of something happening. So let's say I want to know the probability of me moving my left hand, the probability. So I would look at the number of outcomes I have for the left hand, which is 4, and the number of total outcomes, which is 16, and the probability is 1/4. And again, that should also kind of make sense because the left hand takes up 1 out of 4 total mappings. Now there's a difference between probability and odds. So this is what we ended the night on. Odds is a ratio that shows favorable to unfavorable. What it does not show is total. Okay, now there is kind of a thing about that because if I add the favorable outcomes to the unfavorable outcomes, well, that should kind of make sense that I get total. And the reason why is because I either want this to happen or it's not going to happen. And that's all the possible outcomes I could potentially want, right? I can't have something happen and also not happen at the same time. It either has to happen or it can't happen, but that's all the outcomes possible. So in case you forget, a ratio looks like this, A to B. And so that's how we're going to write it. So this is going to be the number of favorable outcomes. And this is going to be the number of unfavorable. So let's look. Let's say we want to spin and land on the color red. So again, in terms of favorable outcomes, I'm going to look for how many times I can land on red. So that's 1, 2, 3, 4. So in terms of favorable outcomes, there's 4 ways for me to do it. And in terms of how many ways I could not land on red, well, there's 4 blues, 4 yellows, and 4 greens. So it's a total of 12. Now again, if I look to unfavorable and favorable, if I added the 4 and 12 together, I get 16, which was, we said earlier, the total number of outcomes. So I hope it makes sense that when we talk about this as in odds, we're actually looking at sort of one side to the other side, and that's really it. How could I spin and land on the right hand color? So if I think about the right hand, that's any of the numbers 5 through 8, and you can see that there's 4 of them, but then there's 12 on the other side. Now, one thing we talked about in class is that always be aware that if you can reduce, both these numbers are divisible by 4, so I'm going to reduce them 1 to 3. So if I divide 4 by 1, I get 4. If I divide 12 by 4, I get 3. And so this is actually the way that we want to leave our answer. And finally, something that would move a foot, well, under the same idea, there is 4 ways to move the left foot and 4 ways to move the right foot. So there are 8 favorable outcomes. And if I look at the other side, there are 4 ways to not move on this side and 4 ways to not move. So 8 unfavorable outcomes. And since these are the same numbers, these have a odds of 1 to 1. So that's kind of a recap of what is probability and how we're going to use it and what is odds. So we're going to talk in module 11.2 now about how to kind of start putting these ideas together. There's going to be times where we add probabilities and times where we multiply probabilities. And we're going to start to talk about how we think about these probabilities. The first thing that we're going to learn about is the complement of probabilities. And when we do that, we're going to think about, similar to the questions where we were looking for how do we not get certain things? Well, that's exactly what the complement is. So when we talk about event spaces, we talk about the possible ways events can occur. So again, each event has a specific outcome. Rolling a dice has a 1, a 2, a 3, a 4, a 5, a 6. Sometimes we care when it will not have a specific outcome, and sometimes we need multiple things occurring. So an example of a specific outcome is, let's say we roll a dice and get 3. Well, that's a specific outcome. Let's say we roll a dice and we don't get 3. I don't need a specific number. What I need is not a specific number. And so this is what we would refer to as the complement. Sorry, I wanted to fix the spelling on that one. And then there's the odds of multiple things occurring. Now, this is what we're going to talk about at the end of 11.2. But let's say I want to flip a coin and roll a dice. So let's say I want the probability of getting a heads and the probability of rolling a 3. If I want both of these events to happen, aka let's say I have a coin in one hand and I flip it, and in the other hand I roll the dice at the same time, the probability of getting both of these things have their own unique value. The probability of rolling a heads is 1 out of 2. The probability of rolling a 3 is 1 out of 6. The probability of both of these events together would be the result of the multiplication of these two events. So 1/2 times 1/6. So these are what we're talking about. Now we're going to do more of that, but this is the general gist of what we're talking about in these event spaces. So let's say we want to roll a fair die. So now remember, this is what dice look like, and each dice has 6 specific outcomes. 1, 2, 3, 4, 5, and finally 6. Now, let's assume all of them are equally likely to happen, meaning that the die isn't a cheat dice and it's not weighted, and meaning if I roll a 1, it's not a surprise. If I roll a 1 and then a 2 and then a 3, like I'm not getting the same things over and over. So what's the probability of the roll being a 3? Well, if we go back to our idea, the number of outcomes desired so what do we want over the number of total well, I only want one thing. I want a 3, but there's only 6 ways for me to roll a dice, so the probability is 1/6. The probability of a number other than 3 is rolled. So now here's an interesting way to think about it. If I don't want 3, I could want the numbers 1, 2, 4, 5, or 6, which means there are 5 ways for me to roll that dice. And the number of possible outcomes are 1, 2, 3, 4, 5, 6. Oops. So this would be the probability 5/6. Now there's a way that we could do this. In probability, 1 means every outcome. We talked about this on Monday night, where we said every outcome refers to 100%. But we know that 1 out of 6 of those outcomes is rolling a 3. So if I take away from every outcome the odds of me rolling a 3, when I subtract, I get the common denominator, and I also get 5/6. So that's 2 ways to think about that problem. Now, what are the odds of me rolling a 7? Well, it's a single dice. 7's not even in the possibilities. So 7 over 6 would be 0. And the odds of me rolling a number less than 7, well, of my possibilities, every single one of them is less than 7. So it would be 6 out of 6, which is 1, meaning this is definitely going to happen. Whereas 0 as a probability means it's never going to happen. So we always fluctuate between these two numbers. So most probabilities are going to be between 0 and 1. And if they're ever above 1, there's a problem. And if they're below 0, it's also a problem. But in the case that you know it's never going to happen or it's always going to happen, 0 or 1 is that representation. Okay, so when we talk about the probability of a complement, it's just going to kind of rehash the idea that if E is what we call the event space, what we want to happen, then this E with an apostrophe is what we want to call the complement. So I'm going to highlight that in red. And so this part in red represents all the things that we don't want to happen. This S in this diagram represents all the possible things in the entire rectangle. So the idea is that it either happens or it doesn't happen leads to the entire probability of it happening. So we can kind of manipulate it a little bit and say, well, if I want something, then I know it's 1 minus the probability of it not happening. And vice versa. The probability of something not happening is 1 minus the probability of it happening. So I just want to reiterate that when we talk about 100% or 1 in probability, we're talking about the entire space as a whole. And so sometimes it's easier rather to calculate an individual value, we calculate everything around it. So, for example, when a single card is drawn from a deck of 52, so if I have my 52 card deck here like this, what is the probability that it will not be an ace? So let's figure out what is the probability of it being an ace. So the number of outcomes we want, there are 4 aces in a deck of 52. And so if 1 represents the probability of every possible draw, if I subtract the probability of the ace, I now am left with the probability of not an ace. So 1 minus 4 over 52 will get me 48 over 52. And we can reduce it by 4. So I think we get 12 over 13. And so we could even think about it, you know, if I remove the 4 aces from the deck in the first place, well, that leaves me with 48 other cards out of 52. So kind of 2 ways to think about that. And so this is just another breakdown to show you what that would be here. So that's what we'll leave it at for this video. I hope that was helpful. Feel free to go back and rewatch any of it. I may include another video of another example of a probability that I didn't quite do. But so you should be able to complete the 11.1 questions at this point, and probably most of the 11, or start at least the 11.2 up to complement questions. We'll continue doing more of 11.2 next week when we all reconvene. So thanks. I hope you have a good rest of your week.